When we think of hypothesis testing, we think of p-values. So what is a p-value? Well, a p-value is a measure of how well or how poorly the data fit the null hypothesis. What does that even mean? Well, okay, so let's dig in. If we're doing a hypothesis test, we're trying to see, is the null hypothesis true? Remember that the null hypothesis is H sub O. So I like to call that HO, right? HO. So we are testing the null hypothesis here. We are given, oftentimes, alpha, which is our probability. Now, because alpha is a probability, we know that's going to be between 0 and 1. And when we find our p-value, p-value stands, you probably guessed it, P stands for probability. So our p-value must also be between 0 and 1. Don't forget the basics about probability. Now, where does the p-value go? Hopefully, when you're doing your hypothesis testing, you're thinking about the normal distribution curve and you're thinking about left-tailed, right-tailed, or two-tailed. Well, first off, if we have a left-tailed test, okay, so thinking something like maybe our null hypothesis is equal and then our alternative hypothesis is less than, right? So when we have less than, we're talking about a left-tailed test. So our p-value is going to lie on the left. Makes sense, right? So left-tailed test, it's on the left. If we have a right-tailed test, then our p-value is going to live on the right tail. This should make sense. With a two-tailed test, if it's two-tailed, then we take the sum of both of those. So we're going to add these two areas together to get the p-value because it's two-tailed, so it's both of them together. That just gives you a visual representation of where the p-value lies if you're drawing yourself a nice normal distribution curve. And I'm a big visual learner, so I appreciate the drawing of the curve just to give yourself a visual. Now, when you think of, well, that's great, but how does this help me? Okay, that's fair. With p-values, in order to use them properly in our hypothesis test, we must compare that p-value to alpha. So we're trying to decide how do these two probabilities stack up to each other. That's the goal. Now, the one thing I always like to say, and this is, I tell it in my class, and I'm like, if the p is low, the hoe must go. I mean, this, remember, this is the null hypothesis. So that's just kind of a nice little chant. If the p is low, the null hypothesis must go. Now, when I say, what does low mean? Well, that's fair. Basically, if the p-value is less than alpha, then you reject the null hypothesis. So if the p is low, then the hoe must go. If the p is less, so if your p-value is less than alpha, then you reject the null hypothesis. So you calculate your p-value. If you need to find that, different video. Calculate your p-value, compare it to your level here, oh gosh, now I'm losing my brain. But you compare it to alpha, and then you go on from there. Okay, so so if I get excited. If your p-value is greater than alpha, then you do not reject your null hypothesis. So, the basics. A p-value is simply the probability of observing a sample statistic at least as extreme as the statistic actually observed if we assume the null hypothesis is true. These are like specific statistical reasonings here. That looks it. The big idea, if the p is low, the hoe must go. So just remember, compare p to alpha. If p is less, then you reject. But p is the probability. P-value is simply a probability of observing your sample statistic. Thanks all.